Afternoon, everyone. Thank you for coming to the conference and sitting through to our talk. My name is Jagane Sundar. My co-founder here is Jitendra. We're co-founders of a company called MLFlow. We develop and market an enterprise MLFlow product. So what are we doing here? We are talking about Concurrent for MLFlow, which we consider as a bridge between two thriving open source communities, MLFlow and Kubeflow. I'll start with a brief introduction to some of the reasons why we started this project and some of the rationale behind some of the architecture choices we made. And then we'll dive straight into a demonstration video that Jitendra will talk through. Next slide. So what is, so brief agenda, talk about the project goal, which is kind of important given the variety of content in the similar space that we've heard all day long. The architecture, a lot of the goals drove our architecture decisions, so we'll talk about that. We'll demo MLFlow, partly because MLFlow is actually a different thing when you consider the enterprise versions that are sold by companies like us and Databricks and the open source version. So we found that many folks in the Kubeflow community are not that familiar with some of the features. So we'll show you some of the things that MLFlow brings. And we'll do a demo of Concurrent for MLFlow. Finally, open it up for questions and answers. Next slide, please. So our goal is pretty simple, actually. Bring together a collection of best-of-breed tools for AI ML users. Now, I think we share this goal with a number of folks here, but we all come at it from different directions. And we are completely open-minded. We're listening to a lot, but we really think that there are strengths to both MLFlow and Kubeflow that end users will benefit from. Next slide, please. So what are the strengths of MLFlow? The experiment tracking system in MLFlow is very well developed. And support from open source libraries like PyTorch and TensorFlow and XGBoost and whatever else is very strong. So auto logging works really well. And the responsibility for keeping the auto logging working now rests on the open source teams building PyTorch and TensorFlow and other things. That turns out to be a very useful thing because oftentimes when you release a new version of MLFlow, the auto logging just works for the most part. We've observed it for the last 2 years, and that's something that end users really benefit from. You don't wake up one morning and find that pip install has installed a new version of MLFlow for you, and your pipelines are all of your work is broken. That never or rarely happens with MLFlow. So tracking is great. Model management, the actual definition of a model and a JSON format that you can use for input and output is pretty sophisticated in MLFlow, and it works really well. Model registry, where you put a defined model into a registry for purposes of sharing. You establish authorization rules as to who can view it, who can edit it, who can put things into production, put it in staging, archiving, that sort of thing are well taken care of with MLFlow. Finally, the MLFlow projects concept is kind of similar to KFP components. It's quite similar, I would say. It's very useful, but this is one case where KFP components can actually work just as well. Next slide, please. So I want to distinguish between two types of MLFlows out in the wild right now. The first one is you use pip install to install MLFlow. It's a single user install effectively. There's no authentication, there's no authorization. It's really not something that's meant for sharing. It works quite well for that limited purpose. But hidden behind that are behemoths like Azure ML and Databricks. And we're not a behemoth, we're a very small company, but we do put in a lot of energy into making some features available that people find useful. Those are the multi-user service type environments. These are offered as a REST endpoint with authentication, authorization, scalability, high availability, disaster recovery, all of these enterprise-ready capabilities built in. So when your MLFlow goes down, it basically means all your data science activity is going to stop. All your Python programs are going to throw some exception and just sit there. In order to make sure that you never have downtime like that, we have all of these enterprise capabilities built in. So two types of MLFlow. We're very fortunate to have such thriving open source community behind us. Next slide, please. So what about Kubeflow? compute management and its Kubernetes first approach is just amazing. And you folks all know the success that it's seen. We believe that this is the only legitimate way to manage compute for AI ML, and I think most community members here would agree with that as well. Notebook management is another problem that's well solved by Kubeflow, and again, unique to this space. I'm going to say batch inference and 24/7 inference. A lot of these capabilities come from different components here, but those are well done in Kubeflow also. MLFlow, because of its roots and because Mate is part of Databricks, they don't believe in Kubernetes as a compute engine, or they don't want anything to do with Kubernetes for compute. Effectively, they think Spark and Databricks is the compute solution. So we find a big gap there, and thereby this effort by us to bridge the two communities. Next slide, please. So I'll finish with one final thought, right? When Kubernetes first came out years and years ago, it was seen as a cloud for the on-prem folks. On-prem hardware, racks of hardware, easy to consume on almost like a cloud basis. That was wildly successful. But off late, what we are finding is that Kubernetes has become a replacement for things like the EC2 API. It is probably fair to say that one of the most successful places for Kubernetes is EKS and GKE and AKE and all the cloud Kubernetes instances. Basically, end users are preferring these APIs to actually talking to EC2 or any of the other VM APIs. And that has value because now Kubernetes is actually much bigger than it was originally conceived. That's always a sign of a great successful product. Now, next slide, please. So this brings us to Concurrent's primary goals. So we started off with this approach that we would build a multi-geo, multi-Kubernetes DAG processing engine. We would acquire resources from whichever Kubernetes the user wants us to use. We would move the data to whichever region or location across WAN lines, perhaps, in order to get the data to where the compute is going to happen. And that was a primary focus for us. It dictated how our control plane will look. Jitendra will talk about that in the next slide. The second aspect, now, both of us are from the Hadoop background, by the way. We worked in HDFS at Yahoo. So large amounts of data, parallelized processing of table data, basically Hive is where we came from. But we looked at it and said, for unstructured data, there's no real solution. So parallelization is an important aspect of Concurrent. Splitting the data, sending it to multiple parallel instances to appropriate nodes is a primary focus. So we'll talk at great lengths about how you partition the data, how you parallelize. Jitendra, that brings us to the architecture.
All right. So we are primarily a multi-cloud and multi-Kubernetes system. So our control plane exists outside the Kubernetes infrastructure. Our control plane exists in cloud. It's based on serverless Lambda functions and cloud persistent key value stores like DynamoDB in AWS. So with this architecture, we can achieve high scale, high availability, and disaster recovery. Now, the primary goal of Concurrent is to take your ML projects and distribute it in the cluster and run it in a parallelized fashion. And those ML projects are stored in Git. So ML project at a high level is your code plus a Docker file or your environment. And this since the ML project packages them together, it gives you the transparency to schedule it anywhere. And since so we support Git integration, therefore it's a very easy development process. You can keep modifying your code or your environment, and we will do the scheduling. So now, based on the Docker file, the container management, the creation of containers, all that is abstracted out. The system concurrent architecture takes care of all that. And the scheduling is across different Kubernetes architecture, Kubernetes infrastructures. Like I will show in the demo that you can develop a pipeline where one stage of processing runs in a Google Cloud versus another stage of processing can run in AWS Cloud. So, and we are, I mean, we have enterprise MLflow service, but Concurrent works with any MLflow service out there. So MLflow service, it's closely integrated in the sense because we all the tracking happens in MLflow, and some of the state management also happens with MLflow, and our UI is also integrated, as you shortly see. But we work with any other MLflow service out there, including open source or Databricks. Okay, so with this, let's jump to the demo.
All right, one second.
The MLflow overview. So first, I will show you an overview of MLflow just to highlight some of the features, capabilities that MLflow offers, and some of our additions there. And then I will show you a concurrent demo. So this is our free service, concurrent free service, which has both MLflow and concurrent integrated into one UI, and they are designed to work seamlessly. So you can see that we have experiments and models, which is MLflow concept, and we have added concurrents on top of it, which is the distributed processing engine. So I mean, usually in MLflow, the first step is to create an experiment, and although your experiments show up on the left, and when you create an experiment, you give it a name, and you can choose an artifact location. When you set up your infrastructure, usually there is a default artifact location, but you can bring your own S3 bucket or anything, and system will write your artifacts over there. So now this experiment is created, and then now, once you specify this experiment ID into your runs through MLflow APIs, your runs will start showing up in here. So like there is another experiment which bunch of runs over here, and all these runs capture all the parameters of the execution and all the details of your run. So like parameter ML related parameters, any matrix. The graph of the matrix. I mean, if your run is long running, you can actually see the graph progressing. Then you can set certain tags so that you can look it up and track the behavior of your experiments. So the model API, I mean, in fact, all the open source library, there's ML libraries support the model API, so you can log your model into MLflow. So this shows up as an artifact over here, along with the model code, along with the binaries, the parameters, and the dependencies. So MLflow has a very nice packaging for the model. And you can manage it very well. Okay, so we capture the code. This is some of our enhancements. Basically, all the parameters of the run along with the code is also captured automatically when you run in our code. The logs of the run are also uploaded into as an artifact. So the complete history is available. This permissions is, yes, the enterprise versions of MLflow support this. So we have role-based access control. For any user, you can specify a reader, manager, or an editor role. We are also actually working on this area to enhance it to support other authorization models as well. So it's a complete enterprise security available there. So next step, like typically in the workflow, once you have a model, a run has created a model, you register a model. The notion of registration, basically you create and give it a name, and then MLflow can track the versions of the model. And with versions, it manages the life cycle of the model. So you give it say a new name here. Create a model with a new name, and we will see that we can do versioning there. So let's go to the model page. Okay, so we stored one version of the model. Let's store one other version of the model, same model, and then we will go to the model page and see. All right, so here we see a model. Now this model has the latest version 2 was added, and then here you control the life cycle. You can say that this model is in production. Then again, you can search through the models, you can associate tags with it. And with the model, we record the run ID. So you can go back to the run which created that model. So this integration is very useful because this gives you the lineage of the model, where it is coming from, all the history that was, all the parameters that were used to create that model. Then yes, permission, same as experiments for models. So this is very important because you now want to share the model across different groups. You want to control the permissions. So that's another important enterprise feature. One more aspect is that look at all the things that are available related to the run, for example, those parameters or matrix. So MLflow gives you capabilities to sort through these when you are searching. When you have done 1,000 runs for an experiment, it becomes difficult that, okay, which run was really good. And so you can sort on those metrics. There's a search bar there. You can search on that metrics. So that all capability comes with MLflow. And another thing very important is people use MLflow for tracking intermediate data as well. So if you go to a run, you can log the output and store the output, and some of the output can be even visualized. So in ML processing, this intermediate data is also very important for debugging or just looking at what really happened going. In fact, for legal requirements also, you may have to track this intermediate data. So it has a very nice little interface. Some of the file types can be visualized as well. And in our compute engine, in fact, this intermediate data can be used as the source data for subsequent processing. So so this integration with the cloud storage in an enterprise MLflow is very useful because now you have all the history of the data, including the intermediate data processing. All right, so now we come to concurrent, and then now we will show how to create a concurrent graph of processing and execute it. Next, we can switch videos.
All right, 1 second.
Concurrent demo set.
Yep.
Yes. All right. So in this, we will create a concurrent graph, and which has simple graph 2 nodes. First node will be executed in GKE, and the second node will be executed in EKS. And we will do data partitioning to parallelize. So we give it a name, and then we'll create a graph. So when we are adding a node, we give it a name, we specify the location and some of the Kubernetes parameters. We have cluster management also, where you can specify cluster details and some of the knobs, so you can bring your own cluster. And this is the Git URL for the ML project. So once this node is created, you add another node. This one, we will specify a different cluster in EKS. We choose some of these parameters. Again, we give the GitHub for the ML project. And now we specify the inputs. So for input, you can choose a bucket, give the name of the bucket. One of the key things is the partitioner. I will briefly talk about what a partitioner does. So partitioner is essentially that decides to partition your keys into different containers. So we have a support for custom partitioner where you can specify any Python lambda function that will basically take your metadata and do the partitioning, or we have inbuilt directory partitioner that will just partition based on the directories in the input. And so we add complete all the inputs there. And now we save the template and just run it. So now when it starts running, see, it's a 2-node graph, but when it starts running, the partitioning kicks in and the first node is split across 3 different containers because we specified the parallelization that, okay, our capacity for 3 containers. And now correspondingly, MLFlow shows that now 3 runs have been launched for this corresponding to the first node. So that's the benefit of having it integrated with MLFlow. And now we can, of course, use the Kubernetes CLI to look at all the logs of execution. We use GKE context and track the progress from Kubernetes. We also upload these logs to MLFlow. That our system takes care of this. So you can, I mean, if user is not familiar with Kubernetes CLI, they can go back to MLFlow and look at the logs and just track the progress over there. They don't have to worry about the Kubernetes CLI. Because if you're working with multiple clusters, I see that switching the context and managing credentials becomes a hassle. So we can see that now 3 containers are actually running corresponding to the tasks, and there is 1 bootstrap container. So these we can look at the logs. Yes, a lot of stuff is happening there. Can we compose? All right, and we see here that it's still in progress. It should be done shortly. All right, so first stage is complete. All the 3 tasks are complete. And now you can see that the second stage has also split across 2 nodes because now when the first stage is complete, our controller realizes that second one is also scope for partitioning, and it does the partitioning based on the parameters. And for second one, we go to the EKS cluster and look at the logs over there. Okay, so this one also shows there are tasks running in the cluster. This is for the first stage was pre-processing of data. Second stage was the classification. So this one is also doing processing. Almost done. All right. So okay. So here MLFlow shows that 5 tasks are done. So okay, yeah. So all the tasks are complete. MLFlow reflects it. Let's look at the graph also, and the graph shows as well that all the 5 tasks are complete. So yeah, so this was a very fast demo because some of the aspects of our system, particularly related to data management and stuff, we could not cover because lack of time. But yeah, we have a multi-Kubernetes system here. Any questions?
I'd like to open it up for questions.
Yes.
So if I understand correctly, Concurrent is an alternative DAG orchestrator, essentially. So is this, I'm trying to think about how the integration would work with Kubeflow. So is this a replacement at the Kubeflow pipelines level, or is this more of a replacement at the Argo level, like the back engine of Kubeflow pipelines? And also Kubeflow is essentially currently limited in the context of a single cluster. Everything happens, is designed essentially to run on a single cluster. So how do you envision this running which are the integration points, I guess?
So first, very simple baby step we are thinking of is that we have ML project that we schedule in a DAG, and ML project is a way of packaging your workload, which is very simple definition. I think Kubeflow components also does something similar, and probably Kubeflow component is a richer interface. So we are thinking that we should support not only MLflow projects or bring them together. And an MLflow project should be able to express a Kubeflow component or vice versa. So that's one area that's one of the baby steps we are thinking.
We are discussing with the community how integration might look. One way is to take a KFP definition and enhance that to support multi-Kubernetes, multi-region. We're also very particular about how data is partitioned because that drives a lot of parallelization features. And if we can enrich the definition so that those details are included, we become an alternative at that level, become an alternative to KFP, but we use the same KFP pipelines. That's one option. So we have the MLflow UI integrated into our system, and we're happy to contribute that to Kubeflow open source along with Kubeflow interfaces, because one of the challenges we see is that MLflow UI inside Kubeflow UI is challenging right now. So we want to take some changes back to the MLflow community and make that integration smoother. So that's a separate consideration here.
Okay. Because the MLflow part, aside concurrent, that's a different story on integrating the experiment tracking and model registry and all that part. That's a whole different story of how you integrate that into Kubeflow and how then this integrates or replaces MLMD, which is the metadata store of Kubeflow. Yeah. But okay, but this is different from the concurrent side of things.
It is tied in the fact that we've already done the work to integrate with MLflow UI, and we'd love to help do that work for Kubeflow to make that integration happen. We've done the work. We talked to Matej, and he's pretty open to a lot of these things. I don't know how much we can push, but he's very encouraging in many of these things. So we'd love to see if we can integrate the two UIs and bring this compute facility into Kubeflow. That's our, it's a slightly different approach, but we do think that Kubernetes is bigger than a single cluster and a single cloud or its end users will definitely benefit from that feature. We run into users who've got GPUs in a different region, who've got GPU-specific clusters they want to use as part of their workflow. It becomes very contrived if you try to put that into different pipelines and kick off one after the other because you have two different Kubernetes clusters. I think the ability to run a single DAG across regions and clusters is very enhanced capabilities.
2 minutes.
Yeah, any more questions?
And sorry if I missed that. How do you register a remote cluster to your control plane? Is that some API level thing?
Yeah, actually our UI has that facility. I can show you afterwards. But there's a cluster management pane. You can add your cluster name and some of the credentials stuff, which system will manage. And in fact, we are discussing to enhance it significantly because we want a lot more administrative control on top of it. Because,
authorization is something people are asking for. So administrator adds a cluster, specifies that this group is allowed to use this namespace in the cluster for this level of capability. That sort of thing is essential for us. Then the end users come in and they specify their namespace and use it. If they try accessing some other namespace, then there's an authorization exception. That's the flow that we're building into the system right now. And the end users should also be able to bring a cluster and say, I'm an end user. And if the administrator of the service allows, he should be able to say, here's my cluster details. I want to use this for part of the DAG. So those are two things that we are seemingly being asked for more than.
Any other questions?
Yeah, quick question. So you are using the Kubernetes cluster in different cloud, or you manage them?
We're using
We are using.
Like create a namespace in that.
no, we're using those clusters.
Yeah, we are
No,
using.
for-
Administrator creates them, we use them. But
So for convenience sake, we do give you a CFP that you can use to create an EKS cluster. We do show you how to create a GKE cluster if you want. But administration of those Kubernetes clusters is not what we are doing.
yeah, we take only two parameters from the user, the cluster name and the namespace. And based on if it's an external cluster user has configured it before, we look it up based on the name and the namespace, all other parameters of the cluster credentials and stuff, so that to hook
Today
it
we have
through.
support for EKS and GKE, so we actually take on the IAM role that is required, supply the external ID. For GKE, we use the JSON credentials file for the service account. We believe we can't get users to use this unless we allow that level of integration. We'll do that for every cloud we support, for every Kubernetes distribution we support. It's just necessary to make things work.
Yeah. So we have realized that this last comment that along with all this infrastructure, there are certain additional things that are must. One is this cluster management. Another is the user data management. User has some data lying in a bucket, they want to bring it into it. So we have interface where user can say, this is my bucket, this is an IAM role, and you can access it. And third is the container management. User gives you a Docker file and you have to manage these containers and make sure they show up in the right place, right? So all those things put together that make the system really usable in enterprise. So those are the things we have supported in the first class manner.
It's all in Concurrent. It's an Apache licensed open source project, and we develop in that tree on GitHub. So feel free to participate and ask questions there as well.
Thank you so much.